Alright, so this is my presentation for Calculus AB Online on applications of calculus in real life. And we're going to get started with my first topic, which is optimization. And optimization is the practice of finding an absolute maximum or minimum of a function. And this can be used in real life in many ways. One of the most common ways is in business and companies. So it could be used to create a product with as little material waste as possible and then sell it for the highest price possible. It can also be used to create budgets using that information, and even can be used to hire the maximum number of employees needed to run a company efficiently, and then figure out how much to pay them so that the company can still make a profit. So my demo is actually a problem that we've used in this course before, and this may not strike you as a business problem, but you could think of it as a fencing business helping this farmer create this pasture for his cows. So they are using optimization to find the least amount of fencing needed to create this pasture of 180,000 square meters. And as you can see, I used optimization to figure out that it would be 600 meters, and that's the minimum amount of fencing needed to create a pasture that large. And this may have to do with how much the pasture costs. Maybe the farmer can't afford a ton of fencing, and that would be a classic optimization problem. So a career that uses optimization is industrial engineering, and industrial engineering engineers use optimization every day to develop and improve systems which are as efficient as possible. They may figure out budgets, they may figure out use of materials and products, or they may even figure out how to place people in a workspace for maximum productivity. They also have to know statistics, interpersonal communication, they have to have knowledge of computers, management, and especially problem solving, because their career is basically problem solving using optimization. So my second topic is differential equations, and differential equations are equations which involve functions and their derivatives, and they're often used to describe change as it relates to time. So you can see how this can be really helpful in real life, and one of the most common applications of differential equations is Newton's law of heating and cooling. That can be used in police investigations to find things like how long ago someone was killed or how long ago a car was driven. I actually listened to a true crime case recently in which they had to figure out how long ago a car was driven, so they used the temperature of the tailpipe and figured out how long ago it was driven by measuring the temperature of the tailpipe then and knowing the temperature of the tailpipe that it would be while driving. And that was really cool because I think it actually was used to disprove someone's alibi in the case. Another common use of differential equations is the Malthusian law of population growth, and that shows how a population changes with respect to time. So an ecologist may use this to see the change in a population of a certain organism over time, and that could be used to see like the environmental impact of certain things. And differential equations can be used in nearly any situation to study and predict the world around us. So my demo actually is showing the steps to solving a raw differential equation in the form of Newton's law of heating and cooling. So if you think about this in terms of a murder victim, perhaps, and you know that the rate at which an object's temperature is changing at any given time is roughly proportional to the difference between the temperature and the temperature of the surrounding medium, then you can use this differential equation right here, the rate of change of temperature with respect to time is equal to negative k. K is the constant proportionality times the temperature minus the temperature of the surrounding area. And since you know that the derivative of the temperature is equal to the derivative of the temperature minus the surrounding temperature, it can be rewritten as you see here, and the solution is the temperature minus the surrounding temperature is equal to the temperature at time 0, which I assume would be just a normal human body temperature minus the temperature of the surrounding times e to the negative k times t. And you're solving for time, so how long has this person been dead? A career that uses differential equations is forensic science, and forensic scientists use differential equations in crime scene investigations to determine time and cause of death. So Newton's law of heating and cooling can be used to figure out time of death for murder victims, like I just said in the demo before. And there are also equations I noticed while researching this that are used to study blood splatters, and those equations do involve velocity and placement of the drops of blood. So I figured that they probably also use differential equations to figure out the velocity of the blood drops, so they can figure out the velocity at which someone is hit by looking at how fast the blood flew from their body, which is super morbid, but they can just look at these blood splatters and know the velocity and know how quickly someone died, which is really interesting. So that is all for my presentation today. Thank you so much for listening in, and I hope that you have a great day.